Have you ever looked up at the night sky and wondered if there's more than meets the eye? Indeed, the cosmos has always been a source of fascination and mystery to us. Since the dawn of civilization, we have looked up at the stars in awe and wonder, their distant glimmers leading us to question our place in the universe. We've spun tales and myths, traced constellations, and sought to understand the celestial mechanisms that govern our world. In this vast, seemingly infinite universe, we find ourselves in a relatively simple cosmic arrangement, a single star system with our beloved sun. It's warm, it's constant, and it's the radiant heart around which our Earth and other planets dutifully orbit. But the universe, as it so often does, offers far more complexity and variety than our local neighborhood might suggest. Enter the intriguing concept of multi-star systems. Picture this. Instead of one solitary star, imagine a group of two, or even more stars, gravitationally bound, orbiting around their shared center of mass. Picture them locked in an eternal ballet, dancing to the music of the cosmos. This is not the stuff of science fiction. This is a reality in our universe, and these multi-star systems, believe it or not, are not the exception, but the rule. Our sun's solitary reign is, in fact, a bit of an anomaly. Most of the star systems in our galaxy are binary, consisting of two stars. There are even systems with 3, 4, or more stars entwined in a complex dance of gravity and motion. Each system, a unique choreography, a unique symphony of celestial forces. So, as we unravel the mysteries of the cosmos, we find a universe teeming with diversity and complexity. We find a universe where stars don't merely exist in isolation, but instead often share their cosmic journey with companion stars, forming intricate networks of light and gravity. So when you gaze up at the stars tonight, remember, you might be seeing a cosmic dance of multiple stars. Understanding the dance of stars in a multi-star system can be tricky, but think of it like a cosmic ballet. Now let's delve into the dynamics of these fascinating multi-star systems. Imagine a couple locked in a passionate tango. That's how binary systems work. Two stars held in orbit by the invisible hand of gravity, pirouetting around a common center of mass. This center, called the barycenter, is the point around which the stars orbit, much like how a dancer spins on their toes. A binary system can be symmetrical, with two stars of similar size, or asymmetrical, with one star significantly larger than the other. And just like in a dance, the movement of these stars is a testament to the balance of power and grace. The larger star has a stronger gravitational pull, but it's the smaller star's nimbleness that keeps the dance going. But what happens when a third dancer joins the stage? The dynamics become more complex, but no less beautiful. This is a trinary system, where 3 stars orbit a common center of mass. The dance becomes more intricate, with each star constantly adjusting its movements in response to the others. It's a celestial game of cat and mouse, with gravity acting as the music that guides their steps. But despite the complexity, the dance remains harmonious. Each star knows its place, its speed, its orbit. They move together, a trio in perfect synchrony, a testament to the amazing balance of forces in the universe. The interplay of gravity and motion is what keeps these multi-star systems together. It's a delicate dance, a performance that has been choreographed over billions of years. And the best part? This dance is happening all around us, in the vast expanse of the universe, a constant reminder of the beauty and complexity of the cosmos. And so, as we look up at the night sky, we're not just seeing stars. We're watching a cosmic ballet, a dance of celestial bodies held together by the invisible threads of gravity. It's a delicate balance, a dance of gravity and motion that keeps these multi-star systems together. You might be surprised to learn that some of the brightest stars in our night sky are actually multi-star systems. These are not solitary lights in the vast expanse of space, but rather clusters of stars bound together by gravity, dancing their cosmic ballet in the darkness. Take Alpha Centauri, for instance. Located just over 4 light-years away, it's the closest star system to us. But did you know it's actually a trio of stars? Alpha Centauri A and B are similar to our own sun, while the third, Proxima Centauri, is a smaller, fainter red dwarf. And despite the vast distance, with a good telescope, you can observe this stellar trio from your own backyard. Then there's Sirius, also known as the dog star. It's the brightest star in our night sky, but its brilliance is a combined effort. Sirius A is a dazzling white star, twice as massive as the sun. Its companion Sirius B is a faint white dwarf, once a star like its partner, but now a stellar remnant after exhausting its nuclear fuel. And who can forget Polaris, our North Star? It's been a beacon for navigators for centuries. But Polaris is not alone. It's actually a triple star system, with two smaller companions orbiting the main star. However, their combined light is what makes Polaris such a reliable fixture in our night sky. These multi-star systems, and many others like them, remind us that the universe is a place of complex relationships and intricate dances. They appear as single points of light in our night sky, but in reality, they are families of stars, bound together by the very fabric of the universe itself. So the next time you spot these stars, remember you're actually seeing a family of stars, not just one. Now imagine being a planet in a multi-star system. What would your sky look like? Well, it's not a simple question. The life of a planet in a multi-star system is a celestial ballet, a dance of light and darkness, heat and cold. Depending on its orbit, a planet could circle one star, just like our Earth circles the Sun, or it could orbit all the stars in the system. Picture this, a planet orbiting a single star in a multi-star system. The other stars would appear as very bright stars in the planet's sky, illuminating the night and creating a spectacle of multiple shadows during the day. But let's take it a step further. What if a planet orbits all the stars in the system? Now that's a different story. This planet would experience periods of intense light and heat when the stars align, followed by periods of relative darkness and cold when the stars are apart. But what about life? Could life exist in such a system? The conditions would be extreme, to say the least. The constant fluctuation between periods of intense light and heat, followed by darkness and cold, would be a challenging environment for life as we know it. Yet life on Earth has shown us that it can adapt to extreme conditions. From the heat-tolerant organisms thriving in hydrothermal vents at the bottom of our oceans, to the cold-loving creatures surviving in the icy landscapes of the poles, life has found a way. This resilience gives us hope that life could also adapt to the extreme conditions of a multi-star system. But it's not just about temperature. The gravitational forces at play in a multi-star system could lead to erratic planetary orbits, potentially causing cataclysmic events like meteor showers and powerful tides. Yet, in spite of these challenges, life could still find a way to survive and thrive in such environments. Despite the challenges, scientists believe that life could exist in multi-star systems. Perhaps we are not alone in the universe. Multi-star systems are not just fascinating, they're also keys to understanding our universe. These complex celestial dances, where two or more stars orbit each other, hold the secrets of the cosmos within their intricate patterns. The future of exploration is brimming with potential as we delve further into the study of these systems. They are like cosmic laboratories, allowing us to investigate the mysteries of star formation, evolution, and planetary interaction. As we observe the birth and death of stars in these systems, we gain insight into the life cycles of stars, including our own sun. Ongoing research is taking us deeper into the heart of these systems. Projects such as the European Space Agency's Gaia mission are mapping out the positions, distances, and motions of stars in our galaxy, with a special focus on binary and multi-star systems. This data is helping us to understand the gravitational dynamics that shape these celestial ballets. In the future, new technologies will enable us to study these systems in even greater detail. Next-generation telescopes like the James Webb Space Telescope will peer into the dusty cradles of star formation, revealing the birth of multi-star systems in unprecedented detail. Similarly, advancements in computer simulations will allow us to model the complex interactions of these systems, predicting their evolution over billions of years. Perhaps most exciting of all is the potential for discovering new planets within these systems. While multi-star systems pose unique challenges for planet hunters, the discovery of exoplanets in these systems could provide invaluable insight into the diversity and resilience of planetary systems. As we look to the future, we can anticipate a deeper understanding of the cosmos, led by our study of multi-star systems. Their intricate dances offer a unique perspective on the universe, one that challenges our understanding and fuels our curiosity. As we continue to explore the cosmos, who knows what secrets these dancing stars will reveal?